Okay, this is just an intro video to the properties of exponentials and logarithms. And the reason I'm doing the intro together is because remember, they share traits. So, first of all, both exponentials and logs need the same base. So, if you're working with exponentials, both exponentials need to have the same base. If you're working with logs, both logs need to have the same base to apply the property. When we're talking about the properties, here are some of the things that we're talking about. The product rule, quotient rule, power rule, zero rule, negative, when exponents are negative, and special bases. We're going to address, well, in this video, what logs are exactly, because that's kind of mysterious. And then what's really important to remember is these two things are inverses of each other. So later on when we're solving equations, you're going to use inverse properties of exponentials and logarithms to solve the equations. Okay, first we're going to address what are logs? Logs are exponents. So if you were to read this in English, this base 2 to the power of 3 is, remember, r is, was, always means the equal sign, is 8. So 2 to the third power is equal to 8. Logs are exponents. That's what logs are. And normally when it looks like this, well, these are integer exponents, but typically when we're working with logs, or originally, it's because astronomers or physicists have to deal with these very, 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 very small exponents. Well, there's not an easy way to figure that out until somebody came up with logarithms. Okay, so what this says is a base of 2 raised to the third power is 8. And normally you are dealing with this kind of stuff. If you had this value and it was a base of 3, what the heck would that exponent be? Well, logarithms and the properties of logarithms help you actually find that exponent. So what are logs? Logs are exponents. Okay, and then the third thing that we need to cover, what about special bases? So, for exponentials, well, 0, if you have nothing, it doesn't matter what you do to it. It doesn't matter if you multiply, divide, if you raise it to a power, you still have nothing. And when the base is 1, well, 1 doesn't do anything. 1 is that very unique number where the answer will always be a number. So 1 to the first power, 1 to the negative 12th power, the answer will always be 1. And then you could have a negative exponent or negative value, say negative 1 raised to a power. Well, these are inconsistent. And so we're not going to have bases that are negatives because, I mean, in applied problems, you typically will. But when we're just talking about properties and we're working with logs, you're not going to have negative exponents. This is why. If you have negative 1 squared, well, that equals 1. But if you have negative 1 cubed, that equals negative 1. And so it's problematic. So for these special bases, 0, 1, and negative 1, you're not going to have those in this course, in any high school course working with properties of logarithms or solving equations. Okay, and the same applies to logs. You're not going to have a base of 0, you're not going to have a base of 1, and you're not going to have a base of any negative number. Okay, that's it for the, let's see now, oops, I want to make sure. Yep, that's it for the overview of properties of exponentials and logs. The next few videos, we will go over specifically these properties and do some examples. All right, that's it for the overview.